Assalamu alaikum and good morning. My name is Farhan Farouk and I'm a solutions architect with Amazon Web Services for Middle East and North Africa. Today we're going to discuss about threat detection and RFID response at scale in AWS. Let's take a look into our today's agenda. We're going to talk about threat detection, how it happens in AWS, what are the remediation mechanism, and finally some sample scenarios. Let's first talk about threat. Threat detection is being believed to be a bit hard. Threat detection itself is the practice of analyzing the entirety of security ecosystem to identify any malicious activity that could compromise the network or infrastructure. If a threat is detected, then mitigation efforts must be enacted to neutralize the threat before it can exploit any present weaknesses within the environment. Threat detection has always been difficult, as I said earlier, and it is becoming more and more of a challenge. Why? It's because of more connected systems and devices that produce large amount of data that needs to be analyzed. Secondly, it's difficult to find the threat in such large pool of data. Right, is similar to finding a needle in a haystack. Third thing is difficult to find and hire good resources, people with the skills needed for this kind of expertise. Expanding on the design principle of threat detection at AWS, we have a wealth of data uh, and information that can be gathered by using services like AWS CloudTrail, service logs, and API CLI return values. Ingesting these information into a scalable platform for managing and monitoring logs and event management, like Amazon GuardDuty, will give you the transparency and operation agility you need to feel confident in the security of your environment. And don't worry about it. We're going to talk about Amazon GuardDuty shortly. From the design perspective, we have three principles when it comes to for a successful threat detection and response. Enable traceability, which basically is nothing but monitoring, alerting, and auditing actions and changes to your environment in the real time. You can integrate logs and metrics with systems to automatically respond and take actions. Second is apply security at all layers. So rather than just focusing on protection of a single outer layer or at your perimeter layer, apply defense and depth principles, with other security controls. Apply to all layers. For example, at the account layer, your edge network, VPC, and at the EC2 systems. Relying on a secure baseline of preventing controls also requires knowing what these controls change. Implementing detective measures to determine drift between secure configuration and current state is another important aspect. Third is automation. Automated software-based security mechanism improve your ability to securely scale more rapidly and cost-effectively. Create secure architectures, including the implementation of controls that are defined and managed as code in version control templates. These three are basically your design principle when it comes to your threat detection mechanism. So, why the threat detection is in cloud is a bit different than your traditional environment. Let's see how your cloud journey begins. In stage one, you start with specific systems. You migrate limited function, limited teams. You have limited accounts. Your foothold is definitely minimal. You're testing. You are doing experimentation. Once you start realizing the benefits of cloud and its scale, you started having more and more presence in the cloud, and you end up in stage two where you have multiple accounts for different purposes, different projects, different team, different departments. Keeping that view in mind, especially the last part of stage two, let's see in the context of an attacker life cycle. Having so many accounts, and if you have an attacker life cycle that could happen into any of your systems, It's difficult to comprehend. For example, the attacker starts with the reconnaissance. Then it tries to establish a foothold. It escalates privileges to some internal records and maintain the persistence. That's what its final goal, to get maximum out of from the victims environment. Putting this methodology in terms of against actual attack or actual event. Suppose that you have an RDP or remote desktop protocol port left open for some reason, and the malicious actor use automated tools that cycle through multiple user and password combination in an attempt to guess the target computer RDP login credentials. Right. The malicious actor then uses DNS to exfiltrate the data. He or she then probe the internal environment by having APIs to get the temporary credentials. Finally, it will attempt to compromise the account in order to remain persistent. This is the typical attacker lifecycle that can happen to any environment, traditional or cloud. Keeping this attacker, parking this concept for a moment, let's jump in how the detection occurs in AWS. We align the AWS security services into five epics of security well-architected framework. Right, the order of the epics tells the whole story with identification services under identification, detection, infrastructure protection, data protection, and finally respond. The detect and respond entails various services offering solutions to versatile security use cases. Right, if you have, for example, AWS S3 Access Analyzer is there to analyze to detect any misconfiguration in your AWS S3, Amazon S3 buckets. Because if you have many multiple accounts, hundreds, possibly thousands of accounts, you must have end up with thousands, if not hundreds, of buckets. How are you going to analyze each bucket with its misconfiguration? So S3 Access Analyzer give that detection capability. Threat detection, without mentioning that the it's data resources, it's not worthwhile. In AWS, you are provisioned with four types of log data. Your AWS Cloud Trail, which is basically your audit trail, whereby it gives you the information of users or services acting in your environment, who did what at what time. Similarly, VPC flow logs, it captures information about your IP traffic going to and from network interfaces into your VPC. It used to monitor the traffic that is reaching to your EC2 instances ultimately. Third is CloudWatch log, with which you can monitor your logs in near real time, coming from different sources again. For example, EC2 or services like AWS Config, for example, or Amazon GuardDuty, which I'm talking about shortly. And finally, your DNS logs that are used by detection service as a part of the analysis of continuous threat detection, and it includes a DNS queries to the DNS results provided within your VPC. These logs are important, and it's always recommended to enable them, to collect and to do a deeper analysis later. So when it comes to threat detection service, we are talking about the data, but what about the exactly service itself? We have two important services, and especially Amazon GuardDuty, which is your threat detection service based, and which uses machine learning and security correlation and alerting. GuardDuty continuously monitors for malicious or unauthorized behavior to help you protect your AWS account and workloads. It uncovers activities such as unusual API calls or potentially unauthorized deployments that includes a possible account compromise. It also potentially detects compromised instances and reconnaissance by attackers. So it's very, very interesting service. That's about Security Hub, which provides a comprehensive view of your high priority security alerts and compliance status across AWS accounts. Amazon GuardDuty can be enabled in literally 3 clicks within Amazon Web Services console. It can analyze and correlate billions of events from CloudTrail VPC flow logs. So when you enable GuardDuty VPC flow logs, it gets data from VPC flow logs, CloudTrail, and DNS logs across all your AWS associated accounts. It performs continuous monitoring using managed rule set, threat intelligence, anomaly detection, and machine learning to detect malicious or unauthorized behavior. It reviews detailed finding in the console, so you can find the findings or the log. That's what we term as integrate it into a management or workflow system, or trigger a lambda function as well for automated response. When you use GuardDuty within AWS organization, you can designate an account within the organization to be the GuardDuty delegated administrator account, so that all the GuardDuty services in all the respective accounts can send all their data in a consolidated fashion into the delegated administrator account. So how GuardDuty works? As I said, GuardDuty collects data from three sources, namely DNS logs, VPC flow logs, structural events. It then correlates it with the threat intelligence, either from third party or from or both, basically, or provided by you, by yourself, to detect any CNC activity or command and control activity. It then runs machine learning algorithms to find any anomalous behavior, for example, change in the network permission set, or usual unusual traffic patterns like large volume of data going out. As a result, CardDD generates findings, right, in terms of high, medium, and low, and send them to different targets, such as Security Hub, S3, or CloudWatch. This is the typical working of Amazon GuardDuty. Now, bring if we bring back the same attacker life cycle that we used earlier when we were describing threats. If you see over here, GuardDuty detects most of these abnormal or unauthorized behavior during the attacker life cycle through its findings, whether it is finding of unusual ports or DNS exfiltration or unusual instance instantiation, for example. It detects it currently provides 70 plus finding types that covers different services ranging from EC to IM and S3. And with time, you're gonna see more and more finding types coming out. AWS Security Hub, we touched a little on it earlier, but it gives you a comprehensive view of your high priority security alerts and compliance status across your AWS accounts. With Security Hub, you have a single place that aggregates, organizes, and prioritizes security findings from AWS GuardDuty and other services like Amazon Macy, Amazon Inspector, and AWS Config. Not only that, you can also get data from your other solutions provided by our partners. For example, if you are running endpoint threat detection platform, or you're running next generation firewall, you can get those data from those sources as well, and it can be aggregated. You can create findings out of it. You can create insight out of it. So what is insight? Insight is basically consolidation of it's basically a consolidation of findings. It identifies the security area that requires attention intervention, right? And insight provides a prescriptive, actionable view on a particular area of AWS security state and enables you to address it. An insight is defined by a combination of specific attributes that we call filters that are applied to all of your existing Security Hub aggregated findings. The result is particular subset of your Security Hub aggregated findings that are included in this insight. So basically, giving you the ability to finding a needle in a haystack. From the scaling perspective, you can invite other AWS accounts to enable AWS Security Hub and become associated with your AWS account. If the owner of the account that you invite enables Security Hub and then accepts the invitation, your account is designated as the management Security Hub account. And the invited account becomes associated as a member accounts. And when the invited accounts accepts the invitation, permission is granted to to the management account to view the findings from all the member accounts. The management account can also perform actions on findings in a member account. So this is how it scales. What's happening is that you are aggregating the data from all your accounts, just like we did for GuardDuty. The all data is consumed into one single management account, whereby you can see the findings and you can take relevant actions. But what about threat response? We talk about detection, but when it comes to threat response, AWS offers different services whereby you can create your automated playbooks or automated remediation patterns. First is Amazon CloudWatch. Amazon CloudWatch provides the ability to record events, right? And with these events, you can fire up different actions. That if certain events is detected, please do this action. And as an action, you can either run AWS Lambda, which is our next service. AWS Lambda, which is a function as a service, is a very powerful tool that you can use to literally do any operation in your AWS infrastructure environment. For example, if you want to open up a if you want to open or close out a security group port, or you want to change your web application firewall rule set, you can do it using a AWS Lambda programmatically as a part of a response or automated response. Similarly, AWS System Manager provides a similar capability, but at your AWS instance level. AWS Lambda, it basically helps you in remediating the issues related to your AWS environment. But what about the EC2 instance? What about if you want to go inside the instance and do some sort of work as a part of your remediation? For example, System Manager allows you to basically deploy automated playbooks by which you can create. You can take a backup, you can run and scan, you can patch the system, or you can simply take the memory dump out of it. Last but not the least is AWS Step Functions. Step Functions perform very important job. It helps in orchestrating between different AWS Lambda functions or AWS System Manager automated jobs, right? What if you have multiple AWS Lambda functions and you want to execute them in certain order or all at once? So Step Functions help in achieving that. Responding to findings or remediation, help is just one example. For example, in Amazon GuardDuty detects any finding, it sends to AWS Security Hub, where it creates an insight, combining GuardDuty finding with probably AWS config, a finding, and sending that single finding to AWS CloudWatch, from where CloudWatch event is monitoring all those events. When it detects that certain specific event is detected, it as a target operation, it either runs your AWS Lambda, simply send the data into S3, send it to as a notification using SNS, right? Or even can run AWS System Manager automated playbooks. In this example, for example, it shows that you don't need Amazon Security Hub for everything. Especially if you're not running anything else, right? If you are just running Amazon GuardDuty in your environment, you can simply use Amazon GuardDuty findings, send it to CloudWatch events, whereby you can again fire certain actions based on certain events. Thus, this is the detailed playbook, which gives you the whole overview of all the services combined together. Advantage of the cloud is having the ability to capture automated events and notification of changes to your infrastructure. You can then feed those changes to Lambda function. That's like happening. This Lambda function could do any number of things. By having the ability to pull together these changes and in a configuration information and act upon them, allows you to ensure you have a good security policies are automated and beginning to end and have a continuous insight into your environment. Let's talk about some simple sample scenarios. In sample scenario number one, the GuardDuty detects as SSH or SSH brute force finding and send it to CloudWatch event. The event rule in CloudWatch even detect this event and triggers step function, which in turns execute three lambda function doing different actions. First lambda function send notification to the SOC uh, communication channel, either Slack or Amazon Chime, to alert the analyst. That's the second lambda function, basically then execute to add the rule in network ACL or NACL to block the particular external IP addresses coming to that particular VPC. Finally, the third lambda function kicks in and adds the tag to the suspected EC2 instance, saying that it's compromised or it is under threat. At the same time, it's instruct Amazon inspector to scan the EC2 instance for any weaknesses. You can see that the services integrates well and creates an actionable security playbook for detection and response. Similarly, you can use many use cases to develop different automated playbooks. Take a look into this sample scenario. Automation helps reduce the amount of noise and manual work. So your security engineers focus on the things which really matters to them. In this example, the finding points to a compromised instance with a finding backdoor like EC2 or that being under DDoS attack, or EC2 it has detected some command and control or CNC activity. Finding collected by a security hub which sends the event to the CloudWatch. Similarly, fashion as we discussed in last example, CloudWatch even alarms triggers lambda function. Instance tag can be checked to see if the automated actions can be taken or if manual intervention is needed. For example, if it's a critical production system. System manager sends the command to shut down the machine, and before shutting down, it captures the memory. Furthermore, system manager removes the server from auto scaling group and snapshots the EBS volume for later forensics. Last but not the least, Lambda functions can kick in and removes instance from the security group, current security group, and adds to one with all ingress and egress blocked. Probably a container security group which has no way of communicating with the outside world except for the administrators. It then moves EBS snapshot and memory data to the forensic account and alerts security team via various third-party tools. You know what? Your forensic data is ready. Please do the analysis, as we have detected some incident and the system has taken some action against the event. I hope you enjoyed the session. It was useful. It was useful, and if you have any query, any questions, please don't hesitate to reach me out. My email address is given. Thank you very much, and have a nice day.